In the vast expanse of space, where distances are measured in light-years and mysteries stretch beyond the reach of our imagination, humanity has always gazed upward, searching for answers. Our universe hides secrets that challenge our understanding, secrets that have inspired generations of dreamers, scientists, and explorers to look beyond our tiny blue planet. Thanks to powerful telescopes like Hubble and James Webb, we now know that many stars are not alone. They host entire solar systems, each with its own collection of planets, moons, and cosmic wonders waiting to be discovered. Among the thousands of exoplanets we've found, one in particular has captured the world's imagination: 55 Cancri e. This extraordinary world, orbiting a distant star, was once thought to be a giant diamond, glittering in the darkness of space. The idea of a diamond planet isn't just the stuff of science fiction. It was a serious scientific theory, born from early data suggesting this planet's interior could be rich in carbon, compressed into diamond by immense pressure. This discovery sent ripples of excitement through the scientific community and beyond, reminding us that our solar system is just a tiny sample of what's possible in the universe. The story of 55 Cancri e is about more than just a strange and exotic planet. It's a testament to how science evolves, how we test bold ideas, and how each new discovery forces us to rethink what we know about the cosmos. Every new world we find adds another piece to the grand puzzle of existence, inspiring us to look up with wonder, curiosity, and a renewed sense of possibility. By studying these distant places, we not only learn more about the universe, but we also gain new insights into our own planet and what it means to be human. The tale of 55 Cancri e is the perfect launchpad for our journey into the unknown, a journey that promises to reveal wonders we can scarcely imagine, and perhaps even more diamond worlds waiting to be found. So, what is 55 Cancri e really like? To answer that, we have to leave behind everything we know about planets like Earth and step into a realm of unimaginable extremes. It's what astronomers call a super-Earth, rocky, but much larger and more massive than our own planet. If you stood on its surface, you'd feel gravity nearly twice as strong as Earth's, making every step a challenge. But the similarities end there. This is a world of extremes, where the environment is more hostile than anything we've ever experienced. Orbiting its star in just 17 hours, it's tidally locked. One side scorched by perpetual daylight, the other plunged into endless night. The planet is so close to its sun that a year passes in less than a single Earth day. The day side reaches a staggering 2,700 degrees Celsius, hot enough to melt not just rock, but even metals like iron. This intense heat creates a global ocean of lava, with rivers of molten rock flowing across the surface. Any mountains or craters that once existed have long since melted away, leaving behind a glowing molten landscape that constantly shifts and reforms under the planet's relentless heat. The dark side, though cooler, is still blisteringly hot. Temperatures there could vaporize minerals, creating bizarre weather systems. Imagine clouds made not of water, but of vaporized rock, drifting through a pitch-black sky. 55 Cancri e was discovered using the transit method, where astronomers watch for tiny dips in a star's light as the planet passes in front of it. This technique allows us to detect worlds hundreds of light-years away. Its extreme nature made it a landmark find, one of the first super-Earths ever discovered, and a window into the wild diversity of planets in our galaxy. It challenged our ideas of what a planet could be. This world is a testament to the universe's creativity, showing us just how alien and unpredictable other planets can be. It's a reminder that our solar system is just one small part of a much stranger cosmic story. It's a place where the unimaginable becomes real, and where the laws of nature play out in ways we're only beginning to understand. And it's only the beginning of what we're learning about exoplanets. With every new discovery, we realize just how much more there is to explore in the universe. The diamond planet idea began with a remarkable discovery. Astronomers noticed that 55 Cancri e's star had an unusually high carbon-to-oxygen ratio. This subtle clue, hidden in the starlight, hinted at a world very different from our own. If the planet formed from carbon-rich material, scientists theorized its interior could be layered with diamond. The possibility was dazzling. Imagine a planet where the very rocks beneath your feet might glitter with unimaginable wealth. On Earth, diamonds form under intense pressure and heat, deep within the mantle. Now imagine that process magnified to a planetary scale, with forces far beyond anything found on our world. the result could be a planet with a heart of diamond, forged by cosmic extremes. Calculations suggested up to a third of the planet's mass could be diamond, buried beneath thick layers of graphite and other exotic carbon compounds. This would make it one of the most extraordinary objects ever imagined in the cosmos. This wasn't wild speculation, but a model grounded in planetary science, based on our understanding of how elements separate and settle during the birth of a planet. The evidence was compelling and the implications were profound. A carbon-based world would have geology and chemistry unlike anything in our solar system. Its mountains, valleys, and even its atmosphere could be shaped by processes we've never seen before, creating a truly alien landscape. The diamond planet hypothesis opened a new frontier in planetary science, hinting at entire classes of planets we'd never imagined. Worlds rich in carbon, with properties and possibilities beyond our wildest dreams. It challenged our assumptions about what planets could be and expanded our sense of what's possible in the universe. Suddenly, the cosmos seemed even more mysterious and full of wonder. Even if the reality is more complex than the original idea, the concept itself was a powerful leap in our understanding, a spark that ignited new questions and new explorations. The universe, it seems, is far stranger and richer than we ever dreamed, holding treasures and mysteries that continue to inspire our search for knowledge. Science is always evolving. As more data came in, the diamond planet theory faced new challenges. Later studies showed 55 Cancri A might not be as carbon-rich as first thought, making a diamond interior less likely. If the planet's composition is more like Earth's, it's probably made of rock and metal, not diamond. Still, some models suggest diamond formation could happen under the right conditions, even with less carbon. The planet's true interior remains a mystery, hidden beneath its molten surface. Scientists use indirect clues, density, gravity, atmospheric data, to piece together the puzzle. Even if it's not a solid diamond, 55 Cancri E is still one of the most fascinating planets ever found. The debate itself has pushed planetary science forward, inspiring new models and creative thinking. Whether diamond or not, this world is a natural laboratory for studying extremes. Sometimes the mystery is as thrilling as the answer. The James Webb Space Telescope changed everything when it detected a substantial atmosphere around 55 Cancri E. Scientists thought such a hot, close-in planet couldn't hold an atmosphere, but Webb found evidence of a secondary one, likely created by the planet itself. The magma ocean below constantly outgasses, releasing vaporized minerals and gases, creating a dynamic, ever-changing atmosphere. This discovery was a game-changer, showing that even the most hostile worlds can sustain atmospheres through geological activity. It's a vital clue for understanding planetary evolution and for the search for habitable worlds. Planets may have more ways to create and maintain atmospheres than we ever imagined. The idea of diamond-rich worlds isn't just for distant exoplanets. Our own Mercury might hide a diamond layer deep inside. NASA's Messenger mission found Mercury's crust is rich in graphite, sparking a theory that intense pressure and heat could have transformed this carbon into diamond. Lab experiments recreated Mercury's interior conditions, showing graphite can become diamond under such extremes. Models suggest a diamond layer up to 18 kilometers thick could encase Mercury's core, helping explain its heat flow and magnetic field. If true, this would revolutionize our understanding of Mercury's geology. Even familiar planets can hold astonishing secrets. Proving Mercury's diamond layer is a huge challenge. We can't just drill down and check. Instead, we rely on robotic missions and clever measurements. The Bepi-Colombo mission, arriving in 2030, will map Mercury's surface, gravity, and magnetic field in unprecedented detail. By tracking tiny changes in the spacecraft's orbit, scientists can detect the gravitational signature of a dense diamond layer. Advanced spectrometers will confirm the abundance of graphite and search for more clues. This mission is our best shot at solving the mystery. Whether it finds diamonds or something else, it will transform our understanding of Mercury's formation. Science is a detective story. Each mission builds on the last, bringing us closer to the truth. 55 Cancri E and Mercury are just the beginning. Our universe is filled with planets stranger than fiction. Some, like HD 189733b, are deep blue gas giants where it rains glass sideways in 8,700 kilometers per h winds. Others, like Tres 2b, are darker than coal, reflecting almost no light. Kelt 9b is hotter than many stars, with temperatures that tear molecules apart. There are marshmallow planets, huge but puffy and low density, and Chthonian worlds, the stripped cores of former gas giants. Some, like Kepler 452b, are rocky and orbit in the habitable zone, hinting at the possibility of life. Each world tells a unique story about how planets are born, live, and die. These discoveries force us to rethink what a planet can be. The universe's imagination is far wilder than our own, and every new world expands our sense of what's possible. From diamond planets to glass storms, exoplanet discoveries have transformed our view of the cosmos. We now know planets are common, hundreds of billions in our galaxy alone. Studying these worlds tests our understanding of physics, chemistry, and planetary evolution. Each discovery, whether familiar or bizarre, helps us understand our own planet and our place in the universe. Missions like James Webb and the upcoming Roman Space Telescope extend our senses, letting us see farther and deeper than ever. The search for new worlds is a search for connection, wonder, and meaning. That's why we keep looking up, reaching for the stars, and dreaming of the worlds that await us.